start. Thermal conductivity by Lee's method, that is the name of your experiment. Now you are going to determine the thermal conductivity of a bare conductor. This is a bare conductor given. You have to determine the thermal conductivity of the bare conductor by using the Lee's apparatus. That is the aim of our experiment. So here to determine the thermal conductivity of bare conductor by using the standard Lee's apparatus, aim of the experiment. Right? Now, when you start the experiment, this is a Lee's apparatus, you can see. Here this is a lower disc, this is the upper disc, right? Here the provision is made to insert the thermometers. Here in the upper disc you can insert the thermometer, in the lower disc you can insert the thermometer. These are the given thermometers. So you can insert it in the upper disc, here like this way. Putting your this way, then you can put the lower disc thermometer here. To note the temperature of the lower disc, you will have to put it, right? Like this way, so that you should be able to note the temperature of this upper disc and the now here this is a flask. Water will become hot, water vapors will form, they will come through this pipe and they will enter the upper disc, right? Now as they will enter the upper disc, there is an outlet here. So keep the beaker here. So when water vapors will be formed, and then after the water vapors will come from here, outlet will be there. So you keep beaker. Now this temperature of it will increase. So you can note down that temperature, rising temperature here. Then a bare conductor is there in between. So this bare conductor you have to keep in between these two. Alright, hold it properly. Keep it exactly at the center. Now heating is going on, the temperature of it will rise. That heat will be given to the bare conductor. Bare conductor will give heat to the lower disc. The temperature of the lower disc also will start rising. One stage will come, a steady state will be reached. What it means? The temperature of the upper disc will rise and it will remain constant. It will not go beyond the certain temperature. That is called as a θ1, steady state temperature of the upper disc. Same will be true for the lower disc. The temperature of the lower disc will rise and it will become steady. It will not go beyond that certain value. That is called as the steady state temperature of the lower disc. θ2 you have to note down. In the observation table, this is the first experimental observation we are taking. Temperature of the steady state temperature of the upper disc, steady state temperature of the lower disc. You follow how to do that? Now it is just you keep your eyes on this thermometer, this red line you can see, that will give you the temperature. This will give you the temperature here, you can see. θ1 you will note down, θ2. What is the condition for that? It should remain steady there, constant there. It will not increase, it will remain there only. And here it will reach that temperature, that will be the steady state temperature, upper disc and the lower. Step 1. Step 2. You follow one, step 2. For step 2, lift this upper disc. Taking the care that thermometer should not fall. Remove the bare conductor and put them in direct contact. And increase the temperature of the lower disc by θ2 plus 10. Means what? Suppose upper disc was 90, lower disc was 70. Now your bare conductor is not there, so whatever will be heat that will be directly conducted to the lower disc, and therefore the temperature of the lower disc will rise fast. And how much it should reach? θ2 plus 10 means 70 plus 10 means how much?
80.
Whatever will be your. 70 is the example. So it will reach to 80 degree. Right? Step 2 is over. Have you followed the step 2? Then after that step 2, once it has reached θ2 plus 10, you will lift this upper disc, remove the thermometer and put it aside. Right? And then put this bare conductor once again. Don't forget to keep the bare conductor. You should keep it. Now what is the temperature of the lower disc now? 80. What is the time now? 0. Now you know that this lower disc will start radiating the heat from the lower surface, and from this side So it will start radiating the heat. What will be the effect of that? Temperature of it will decrease. You have to note down the temperature of the lower dish with respect to time. So time is 0. What is the temperature? 80. Now time is 30 seconds. What is the temperature? 60, 90, 180. Go up to theta 2 minus 10. Theta 2 minus 10 is how much?
70.
Theta 2 minus
Minus 10. No,
is 60.
90.
60. Theta 2 70 tha. Theta 2 was 70. Theta 2 plus 10 is 80. So theta 2 minus 10 is 60. So you have to start from 80. You should reach to 60. And with respect to time, interval will be 30 seconds. 30, 60, 90, 120. As the temperature will reach 60 degree, you will stop heating the. You will find that as the time goes, the temperature of the lower dish decreases. How it decreases? That you have to plot a graph of theta against. This is a graph, right? This is the third part of the experiment. Experiment is over. Means observation part will be over. So I have followed the 3 steps. Follow the 3 steps carefully because you cannot go back. If you make error in any one step, you cannot go back because it is a heating process. So once again you have to start from the first. First step, steady state temperature. Second step, remove the bare conductor, keep them in direct contact. The temperature of the lower dish should rise by theta 2 plus 10. Third step, remove the upper dish and keep it here. Bare conductor once again and note down the temperature of the lower dish with respect to time. 30-second interval up to theta 2 minus 10. Got it? But here it is a continuous process. Otherwise after 30 seconds you will stop and take the reading. This should not happen. Because heat will be radiated continuously. So your eye should be there on the watch. As soon as it becomes 30, note down. As it becomes 60, you note it down. Up to 60 degree you should be alert and note down the temperature of the lower dish. You cannot have a break because you will have a break, but this will not have a break in radiating the heat. Because I have found that some of the students 30 seconds हो गए stopwatch बंद करके इधर देख. That should not happen. It is a continuous process. It will be radiated continuously. So therefore, with respect to time, you have to move it on. Take 5-6 minutes में तुम्हारा पूरा reading होगा. And once it is over, then that preliminary part, you have to measure the mass of the lower dish. It is given here, 870 gram. This part is it. Then diameter of this you can measure by vernier. That is given. Then the thickness of it you can measure by the screw gauge, right? And here this way you can measure the thickness of it. Alright. Then at different 10 positions you have to measure. Zero error is there in the screw gauge, you find out. Least count of it should be known to you. Vernier calipers least count you should know. Main scale reading, circular scale reading, total reading you have to take it at 10 different positions. Then if zero error is there, corrected reading will come. Otherwise whatever reading will get, you will write it here. Then take the mean of that. That is called as the mean thickness of the bare conductor. Then each reading minus mean, that is xi minus x bar. You have to find out. Then xi minus x bar square. And then by using this formula, you can find out the standard error. Where n is equals to 10. How many number of observations you have taken? 10. So n into n minus 1 into 10 minus 1. So that is standard error in the x you have to find out, that is x. Now once you know all this, plot the graph. Then slope of the graph you have to find out at theta 2. And once you know that slope of the graph and all these preliminary observations, here formula is given to find out k. Alright, k equals to 4 m, mass of the lower dish, specific heat is given. Then x you have just obtained, thickness, d diameter, theta 1 minus theta 2 means difference of the two upper steady state temperatures, and d theta by dt at theta 2 means you have to find out the slope at theta 2. Draw the tangent to the curve and find out the slope of the curve, slope of that tangent, and here you have to write. And then finally you write the thermal conductivity is how much. By formula you obtain it and write the answer. Then you can find out the error in k by using this formula. But that I will explain you how to find out once you get the value of, right? So this is the whole procedure of the experiment, thermal conductivity by this. Have you followed the experimental procedure? Okay, then you can see. Now here put this here because now heating is on, so you should continue with the heating is going on. Stop.